Good everyone, my name is Graphics. Today we want to analyze this question that says that given that v is equals to 1 all over the square root of s squared plus y squared plus z squared, show that the square v over the s squared plus the square v over the y squared plus the square v over the z squared is equals to what? 0. Now we have three different independent variables here, which are in the likes of x, y, and z. And we are told to differentiate v with respect to what? Each of those variables. So we are going to differentiate them partially, right? So what we'll do here is this. We'll first of all look for the square v over the s squared. We'll look for the square v over the y squared. We'll look for the square v over the z squared. And we're now going to add everything together. So when we add them together, we're expected to have 0 as our final answer. Alright? So let's start. So now, the solution here. The solution here is, if we are to look for the square v over the s squared, first of all, let's write our question back. We say that v is equals to what? We have 1 all over the square root of x squared plus y squared plus z squared. Right? Now, if I'm to rewrite this again, I am going to be having v equals to what? 1 all over x squared plus y squared plus z squared raised to the power of what? 1 over 2. Right? Because we have this, recall, 1 over what? Ax is equals to what? A raised power minus x. So that is how it is. The power will have what? A negative sign. So from here, this will now give us v equals to what? X squared plus y squared plus z squared raised to the power of what? Minus what? 1 over 2. Now, from here, we will now differentiate v with respect to x. So I'll write differentiating v with respect to what? X. Right? So we are going to be having the v over what? The x. Now, since it has a power here, we are going to be using chain rule. How? I'm going to rewrite my question back here. X squared plus y squared plus z squared raised power minus 1 over 2. You know when you have xn, you're differentiating it, it's going to give us nxn minus 1. Alright? So that is the principle we're going to use here. We call it the power rule. So if by bringing a minus 1 over 2 to the front, minus 1 over 2 to the front, right? I'm going to subtract 1 because I've brought it down. Now, I am not going to differentiate x because I'm differentiating v with respect to what? X. So if I differentiate x squared, I'll be having what? Multiplied by what? 2x. Right? So this is what I have here. Now, if you look at it very well, these 2 will equate these 2, remaining minus 1 and x. So minus 1 times x will give us minus what? Minus x. So into brackets, x squared, right? Into bracket x squared plus y squared plus z squared goes to the power of what? Minus 3 over 2. Because minus 1 over 2 minus 1 minus 3 over 2. How? if I have my minus 1 over 2 minus 1, 1 is the same as saying 1 over 1. The LCM is what? 2. 2 into is what? 1. 1 times minus, I'll give you minus 1. 1 into is 2. 2 times, I'll give you what? 2. So we're having minus 3 over 2. That's how we come about this. Right? Now, we've gotten this. So this is our dv over what? Dv over the x. Now, what are we looking for? We're looking for the square v over the x squared. So that means we're going to differentiate the v again over the x so that we get the square v over the x squared. So when I say that, from here, the square v over what? The x squared will now be, now what do you notice? We have two different variables multiplying each other in terms of x and in terms of this. Right? So we are using product rule here. So the short way for us to use product rule is that what? If you differentiate the first one, you keep the other one constant. So if I differentiate x, I will have what? Minus 1. So I keep this constant, which is what? X squared plus what? Y squared plus what? Z squared raised to the power of what? Minus 3. Right? Plus, now you differentiate the other one and keep this constant. So I'm going to write my minus x, right? And I'll keep the, my minus x, I'll keep it constant, and I'm going to differentiate this. So I'm differentiating this, let me give space here. I'm differentiating that, let me give space here. I'm going to be having, I'll write back this question, which is what? Because it's chain rule. So it will be x squared plus y squared plus z squared goes to the power of what? Minus 3 over 2. So if I bring a minus 3 over 2 to the front, I'll be having bracket minus 3 over 2. So I must subtract 1 here because I brought it to the front. Now I'll now differentiate x again. This x squared, that will give over 2x. So multiply by what? 2x. Is that okay? Now if you look at it very well, this will now give me minus 1, that is minus bracket x squared plus y squared plus z squared open bracket minus 3 over 2. Now minus times minus is plus, so we have plus, we have 2 we equate to remain x, so 3 times x will be having what? 3x. 3x what? 3x squared, because x times f is x squared times 3 give you 3x squared, and minus and minus give you what? Plus. So open bracket, we are going to be having x squared plus y squared plus z squared open bracket minus 3 over 2 minus 1 give you minus 5 over 2, just like I did this. Same thing we applied there, right? Now if you look at it now, I want to allow factorize, since I have almost the same thing at both sides, but not truly the same thing, because the power of this is minus 3 over 2, the power of this is minus 5 over 2. So I will take this out. So if I'm taking it out, I'm going to be having this equals to, I'll have x squared plus y squared plus z squared to the power of what? Minus what? Minus 5 over 2, right? Then open the big bracket. So what is close to this guy? What is close to that guy? Minus 1 is close, so I'll leave the minus 1. I'll leave the 3x squared close to it here, because that is what is close to it, right? Because this time this will give us this. Now minus, I'll write out this back, which is what? X squared plus y squared plus z squared all to the power of. Now the question is, what will I multiply with 5 over 2? That will give me what? Minus 3 over 2. So that's what the question is. What are you going to multiply by 5 over 2? That will give you what? Minus 3 over 2. So let's see. If I say minus 5 over 2 here, minus 5 over 2, plus 1, right? If I look for what I'm looking for, that is, the LCM here is 2. 2 into 2 is 1. 1 times 5 is minus 5. 1 into 2 is 2. 2 times 2 is what? Is 2. So minus 5 plus 2 give you minus 3 over 2. So that is what? We have 1. Because since they are the same, the index is minus 5 over 2 plus 1 will give us what? Minus 3 over 2. So that is why we're using that. So I'll close up. I'll close the bracket here. Now if you look at it very well now, this I did here is the square v over what? The x square. Now to avoid repetition of this same thing, to not waste our time, because we need to undergo the same process and it take virtually almost all our time. So we are going to now implement this in the next question. So the first one is that now differentiating from the first one, similarly, you write similarly this is the square v, this is the square v. Now we are looking for what? The square y over what? The y square. So the square y, this square y, the square v over what? The y square, right? So we write everything, but what will change? Only x here will change. So we're going to have x square plus y square, right? Plus z square raised to the power of what? Minus 5 over 2, open bracket. So this will now be 3y square minus bracket x square plus y square plus z square. I'll close it up and I'm having 1, and it's still the same thing here because I am dealing with what? Y. So if I do in times of z, so this for my times of z, the square v all over what? The z square will now give me, I'll write my x square plus y square plus z square to the power of what? Minus 5 over 2, open the bracket, right? So since I'm dealing with z, I'll be having 3z square minus bracket x square plus y square plus z square, right? And I'll close it up. So this is the 3 of them. So this is the 3 of them. Now the 3 of them here that we have is, it says we should add 3 of them, we should have 0. So I'll call this to be my equation 1. This will be my equation what? 2. And this will be what? My equation what? 3. So I'll put it this way by saying adding equation 1, 2 and what? And 3, right? So we'll do that, and that will be in the likes of, I'll have from here the first one, which is this. I'll be having x square, right, plus y square plus z square minus 5 over 2, open bracket, 3x square minus x square plus y square plus z square. I'll close the bracket back. That's for the first equation 1. So we should add it together with what? Equation 2. That says x square plus y square plus z square, open bracket, minus 5 over 2. Open this bracket here, we have 3y square minus x square plus y square plus z square is the power of what? 1, and that's what we have here, right? Then plus, now plus plus the same thing. We have x square plus y square plus z square with power of what? Minus what? 5 over 2, right? Open bracket. We have, let me just put it here. We have, if you open the bracket, we have 3z minus s square plus y square plus z square. I close it up, right? So that's what we have there. And we're adding everything together, so they must give us at least 0. So from here, from this point, we'll start adding. Now if you look at, they're all like terms, right? So I should bring what they have in common. This is here, and this is here. So I'm going to bring them out. So what they have in common? So we have x squared plus y squared plus z squared, open bracket, minus 5 over 2. They have in common. So I'll open the bracket. So what is remaining? I'm having 3x squared minus bracket s squared plus y squared plus z squared. I'll close it up, right? Plus 3y squared minus bracket s squared plus y squared plus z squared, close brackets, plus 3z squared minus s squared plus y squared plus z squared. I'll close it up. So what are we doing? We have just successfully factorized. So from here, if you collect like terms here, I'll have x squared plus y squared plus z squared. I'll close the bracket. This power minus 5 over 2. Opening up, 3s squared plus 3y squared plus 3z squared, right? Then minus, this is 1 into bracket s squared plus y squared plus z squared, plus, because they're all minus 1 of this, minus 1 of this, minus 1 of this, give us minus 3 of this. S squared plus y squared plus z squared, right? I'll close it up. Now the way it is now, you can easily factorize this by bringing the 3 out, or I will expose this out. So in exposing it out, this will give us s squared plus y squared plus z squared to the power of what? Minus 5 over 2, right? Open up. What they have in common? We have 3x squared plus, or better say 3s squared, 3 into bracket s squared plus y squared plus z squared. I factorize 3 out. Minus 3 into bracket s squared plus y squared plus z squared. I'll close it up. Now what do you notice? They are the same thing. I have this and this, but the signs are different, so they'll cut out. So we're having 0 remaining. So when I say that, my s squared plus y squared plus z squared to the power of minus 5 over 2, open bracket, we have what? 0. Now 0 multiplied by anything is equals to what? 0. Right? So from here, we say that what? Our equation is what? Is proved. Is that okay? So if you found this video helpful, please don't forget to click on the subscribe button, and don't forget to click on also the like button. Thanks for watching.